Good morning friends, I welcome you all for my YouTube channel. So in previous session we were discussing about determinants. We have solved a couple of problems from the second exercise, that is up to 7 problems we have solved. Let us start with the 8th one, right? So 8th one is having 2 sub questions, okay? So in first sub question 1a square, 1b b square, 1c c square should be proved as a minus b minus c into c minus a. In second one same thing. 3 cross 3 determinant is given, which has to be proved as a minus b into b minus c into c minus a into a plus b plus c. So how to proceed this thing, right? How to get the solution? Let us have a look at that. Okay. LHS is equal to 1a square, 1b b square, 1c c square. Okay, let r2 changes to r2 minus r1 and r3 changes to r3 minus r1. So r2 changes to r2 minus r1 and r3 changes to r3 minus r1. So what happens to LHS? First row remains same. Second row r2 minus r1. 1 minus 1 is what? 0. This becomes b minus a. This becomes b square minus a square. And r3 changes to r3 minus r1. r3 minus r1. 1 minus 1 is 0. c minus a. c square minus a square. So now it is easy for us to expand through first column because 0 and 0 are there. Expanding it through first column. So what do we get? This becomes C plus minus plus. Alright, so 0 and 0 doesn't matter, it becomes ultimately 0. So only thing, first value remains 1 into determinant. 1 is there in first row and first column. So leave first row, leave first column. What remains inside? That becomes the determinant. C minus a, c square minus a square. So this can be written as b minus a. B square minus a square can be written as b minus a into b plus a. Similarly here c minus a and c minus a into c plus a. So now I can take b minus a common from first row and c minus a common from second row. b minus a into c minus a. So what remains? b minus a is gone, 1. Here b minus a is gone, b plus a. And here c minus a is gone, 1. c minus a is gone, c plus a. Okay. So now this can be written as b minus a, c minus a. If I expand this determinant, 1 into c plus a, that is c plus a minus 1 into b plus a. So that becomes b plus a. So b minus a into c minus a, right? So plus a minus a cancels. So what remains? C minus b, right? So b minus a, c minus a, c minus b. So what we got? What we want? A minus b, b minus c, c minus a, right? So b minus a, if I reverse it, it becomes minus of a minus b, and this if I reverse, it becomes minus of b minus c, right? A minus b into c minus a into minus of B minus C. So now minus and minus becomes plus. So what remains? A minus B, B minus C into C minus A. This is how you need to prove it. So I hope you have understood this one, right? This is so simple. So with the help of the same thing, with the same concept, let us proceed for the second one. What is LHS? LHS is 1, 1, 1, A, B, C, A cube, B cube, C cube. See there, here 1, 1, 1 was along column, so we operated row. Now 1, 1, 1 is along the row, so let us operate it through column. Okay. Column 2 changes to column 2 minus column 1, and column 3 changes to column 3 minus column 1. So LHS will be equal to what? See, column 2 is changing, so no change in column 1. 1A, A cube. Column 2 changes to column 2 minus column 1. 1 minus 1 is 0. This is B minus A. This is B cube minus A cube. And here 1 minus 1 is 0. C minus A. C cube minus A cube. Okay. So now it has two zeros. So let us expand it through first row. Plus minus plus. So 1 is there in first row and first column. So leave first row and first column. What remains? B minus A, C minus A. This will be 1 into B minus A, C minus A, B cube minus A cube, C cube minus A cube. Right? B cube minus A cube and C cube minus A cube. Now what is B cube minus A cube? It is of the form A cube minus B cube. What is A cube minus B cube? A minus B into A square plus B square plus AB. So B cube minus A cube can be written as 1 into, so B minus A as it is, B cube minus A cube can be written as B minus A into B square plus A square plus AB. And similarly, C minus A as it is, C cube minus A cube, C minus A into C square plus A square plus AC. Right? This is how it can be written. This is of the form A cube minus B cube. This is the expansion of A cube minus B cube. Okay. So now here you can see in first column B minus A is common. In second column C minus A is common. So taking out B minus A from first column and C minus A from second column, so what is left is B minus A into C minus A, 1, here B square plus A square plus AB, here 1, here C square plus A square plus AC. Okay, so this is how it will be there. So B minus C and C minus A have come out. Now we want A minus B into A plus B plus C, right? Sorry, B minus C into A plus B plus C. So let us look out. So if I solve this determinant, what will be left? B minus A into C minus A into 1 into this one, that is C square plus A square plus AC minus B square plus A square plus AB into 1, that is B square plus A square plus AB. So this will be B minus A into C minus A into c square plus a square plus ac minus b square minus a square minus ab. Okay, so plus a square minus a square will cancel. So what remains here? B minus a into c minus a into c square minus b square plus ac minus ab. Okay, so now this is b minus a into c minus a. What is c square minus b square? There is c plus b into c minus b. C plus b into c minus b plus a, if I take common, c minus b. See, c square minus b square I have expanded here, and out of ac minus ab I have taken a out, so what remains? C minus b. B minus a into c minus a, right? So here also I have c minus b, here also I have c minus b. Take c minus b out, then what remains? C plus b, then plus a. C plus b plus a. So here c minus b is coming out, c plus b remains, c minus b come out, only a will remain. Okay, so this is nothing but b minus a, that can be written as minus of a minus b. Okay, c minus a and minus of b minus c. C minus b I have written in the reverse form, that is minus of b minus c, and this is a plus b plus c. So now minus into minus becomes plus, so this becomes a minus b into b minus c into c minus a into a plus b plus c. Right? This is how we need to prove it. Is that clear? Okay. So I hope the concept is clear here. So you pause the video and make a note of this. So friends, I hope you have understood the previous problem. Let's proceed with the next one, that is ninth one. Here there is a 3 cross 3 determinant which has to be proved as some value in the RHS. That is x minus y, y minus z, z minus x into xy plus yz plus zx. LHS is x square yz, y square, zx, z square, xy. So now what I will do, I will multiply x and divide by x for the first row, multiply y and divide y to second row, multiply z, divide z in the third row. So what I am doing, I am multiplying x to first row and dividing x by first row, multiplying and dividing second row by y, multiplying and dividing the third row by z. So here what will be there? X square by x, x cube by x, xyz by x. So divided by x, whatever is coming here, I will take it outside. So it becomes 1 by x. So here whatever is coming divided by y, I will take it outside. So it will become 1 by y. So whatever z comes here in the denominator, I will take it outside. So it becomes 1 by z. So this becomes 1 by xyz into, so x I have divided, that came out, y I have divided to second row, that came out here, z I have divided to the third row, it came out as a denominator. But whatever I multiplied, that is still there in the numerator part of this. This is like x into x by x into x by x into x by x. So divided by x will come out. Similarly divided by y, divided by z will come out. So it becomes divided by x divided by y divided by z. Okay. But x is still there in the numerator. So that can be written as x square x cube and xyz. So here it becomes x square, here x cube, here xyz. So here y square, y cube, xyz, z square, z cube, xyz. So I hope you have understood. Whatever I am multiplying, I should divide it. Right? So if I am multiplying by x, I should divide it by x also. So whatever is divided by x, that came out as 1 by x. Whatever is divided by y, that came out as 1 by y. Whatever was divided by z, that came out as 1 by z. So 1 by x into 1 by y into 1 by z was outside. So that was nothing but 1 upon xyz. So whatever was divided, that I have taken out. Whatever was multiplied, that I have kept inside. So multiplied, x was multiplied with x, it becomes x square. X square was multiplied by x, so it became x cube. Similarly, yz was multiplied by x, so it became xyz. Similarly, that was the case for second row and third row also. So now here you can observe xyz, xyz and xyz is there. So from column 3 I can take xyz outside. So it becomes xyz by xyz, x square, x cube, 1, y square, y cube, 1, z square, z cube, 1. So now this xyz cancels. So what remains here is x square, x cube, 1, y square, y cube, 1, z square, z cube, 1. So I hope you have understood up to here. I have there is no doubt or no queries regarding this. So if at all you get anything, you can comment me in the comment box. There is no issue. I will get back to you people. Right. So till now, I think it is clear. Right. So now this was our LHS. Now as we have 1, 1, 1 in third column, so I can get some zeros in the third column. So that is R2 changes to R2 minus R1 and R3 changes to R3 minus R1. So our LHS becomes, see we are operating for R2 and R1, R2 and R3, so there is no change in R1. Right? R1 is kept as it is. X square, x cube, 1. So R2 changes to R2 minus R1. So R2 minus R1 means y square minus x square. Okay. Y cube minus x cube. 1 minus 1, 0. Z square minus y square. Z cube minus y cube. 1 minus 1, 0. So this is what we will get, right? So if we operate the row transformations. Okay. So now as we have two zeros in the third column, so let us expand the determinant through third column. Expanding through third column. So what we get, see this is plus, this is minus, right? So third column first element is 1, so this becomes 1 into, this is there in first row and third column, leave first row and third column, so what remains, y square minus x square, y cube minus x cube, z square minus y square, z cube minus y cube. Okay, so this is what which is remained here. So this one I can apply a minus b, the a square minus b square, the whole a square minus b square formula for first column and a cube minus b cube for second column. So this will become y minus x into y plus x, and here y minus x into y square plus x square plus xy, that is a cube minus b cube formula. So this is z minus y into z plus y. Here z minus y, z square plus y square plus zy. Okay. So here y minus x is there, y minus x is there, z minus y is there, z minus y is there. I can take them out. So what remains? Y plus x, z plus y. Here y square plus x square plus xy. Here z square plus y square plus zy. Okay. So now I can solve the determinant here to get the value. Okay, I can solve the determinant to get my value. So this will be y minus x into z minus y into y plus x into z square plus y square plus zy. This into this minus this into this. Z plus y into y square plus x square plus xy. Right? That is how it will be there. Okay. So now if I expand this, what will I get here? Y minus x into z minus y as it is. Here y into z square, y z square, y into y square, y cube. Okay. Y into zy. So plus y into zy is y square z. Okay. So minus z into y square z. So 1 minute. X is remaining. Okay. So x into z square plus xz square, x into y square plus xy square, x into zy, xyz. Okay. So this completes multiplying with y and x. Now we need to multiply this one. Open up this bracket. Z into y square z, z into x square z, z into xy z. Okay. Now plus y into y square, y cube, y into x square y, y into xy square. So this completes multiplying, opening all the brackets. Right. So this will be y minus x into z minus y as it is. Open these brackets. Yz square plus y cube plus y square z plus xz square plus xy square plus xyz minus y square z minus x square z minus xyz minus y cube minus x square y minus xy square. Okay, this will be the entire value inside. So now yz square, do we have yz square anywhere? Check it out. So yz square, we are not having it anywhere. Leave it. Y cube plus y cube minus y cube will cancel. Then y square z. So here I am having plus y square z. Here I am having minus y square z. So that will cancel. So what remains? Think of xz square. Do we have it anywhere? No. But xy square plus and minus, they will cancel. Okay. So and plus xyz minus xyz will cancel. And do we have, sorry, xy square, right? This will cancel, right? Plus xy square cancels with minus xy square. Plus xyz minus xyz, right? Then plus y cube and minus y cube is already cancelled. So yz square we don't have anywhere, right? Then xz square we're not having it anywhere, right? Then x square z and x square y. So this is nothing but y minus x into z minus y into yz square plus xz square, right? Then minus x square z, right? Minus x square y. So what we need to prove, xy plus y. We are already having x minus y and z minus y. What we want, z minus x and xy plus yz plus zx. Okay. So do we have anything here which can be cancelled? So you cannot cancel it out. So you can take something as common, right? So let's just check it out. Anywhere any issues? Yz square. See, y into z square, yz square, y into y square, y cube, right? Y into zy, that will become y square z. X into z square, xz square, right? Then x into y square, xy square, x into zy, xyz, minus z into y square z, z into x square z, z into xy, xyz, then y into y square, y cube, y into x square is x square y into xy is xy square. This is up to here, it is clear. Why we need to confirm is any small mistake over here will consume your lot of time. Okay, so this part up to here is clear. So yz square plus y cube plus y square z plus xz square plus xy square plus xyz minus y square z minus x square z minus xyz minus y cube minus x square y minus xy square. So yz square we are not having anywhere, so leave it. Okay, so yz square we are not having, but we are having y square z here, right? We are having y square z. So y square z, just a minute. Yeah, we are having y square z. So everything will cancel and this will remain here. Now I can take y minus x into z minus y. Okay, I will write this xz square minus x square z plus yz square minus x square y. Okay, y minus x into z minus y. I can take xz common. So if I take xz common, what remains? Z minus x plus, if I take y common, what remains? Z square minus x square. So this is y minus x into z minus y, right? Xz into z minus x plus y into, what is this, z square minus x square? Z plus x into z minus x. So now I am having z minus x here, z minus x here. Take z minus x common. Y minus z minus x. So z minus x gone. What remains? xz plus y into z plus x. Okay, so this is y minus x into z minus y into z minus x into xz plus yz plus xy. Okay, what we want? We want x minus y, but we have y minus x, right? So if I convert it into x minus y, it becomes minus, right? Y minus z is needed, but we have z minus y. If I convert into y minus z, so what becomes? It also becomes negative. So this becomes negative, this becomes negative. So z minus x, we already have it, right? So negative into negative becomes positive. So I can write this as x minus y into y minus z into z minus x into xy plus yz plus zx. Is that clear? So this is what which was required here. This is what we have done. It is a little bit lengthier, but what is there here? It is very simple. If you are following the steps very clearly, very slowly, if you are going through, then it is not at all a problem, right? You can get the answer very exactly whatever is required there. Okay, I hope the concept is more clear, right? So why I repeated here, why once again I rechecked this thing is, if ever you make any mistake here, right, in simplification process, then you will never end up with the answer. Okay, so for that purpose, it is very mandatory for us to cross check once again whatever we have simplified, because the simplification process is very lengthy here. So there is every chance that you may make any mistake. So whatever we have simplified, whether is it correct or no, that is very important. So we need to verify it again and again. 1 or 2 times if you verify, it will take 1 or 2 minutes extra, but it will make, if any corrections are there, then it will let you know that things, right? So with this, we are going to end up this session here. So today we have solved 3 problems. All 3 problems were unique. We have solved them. It was easy and unique, right? So with these 3 problems, we are going to end up the session here. So you can take up the remaining problems. You can try it by yourself. So if ever you get any doubt, you can contact me through comment box. I will get back to you, right? So or else you can wait for the next video. You can be tuned with my channel for the next video. So all the solutions will be available in upcoming videos. Okay, so with this we'll stop the session here. Take care.